Okay. Okay, here we go. Okay, first of all, what is a chemical reaction? What is a chemical reaction? First of all, what are the clues of a chemical reaction? Every time you have visual signals that there is a change, for example, a change in color, or a gas is released, or a solid precipitates, or you touch and you can change in the walls of the beaker, for example, that there is a change in temperature. It can be, for example, or is hotter or is colder. Depends on if the reaction is exothermic or is endothermic. Got it? And also, there are, well, I told you, a change of odor also. And that's what is happening during the decomposition of any kind of food. You can smell bad, and then you say, oh, there is a chemical reaction over there. Also, the chemical reactions can produce light or sound. For example, when you have a gun, let me see, somebody else is trying to go in. Okay. Ah, Mireya, oh, Mireya, you were out for a minute. I was telling Connie about the different clues of a chemical reaction. I told her about change of temperature, a change of color, a smell, bubbles, precipitates, sound, and also light. Okay, all these are clues that tells you, oh, I am in front of a chemical reaction. Okay, look, the color changes, a solid forms, bubble form, heat, flame, or also light or sound. That is not here. Okay, somebody else, Anna Ray.
She said her sound was messed up.
Okay, Anna Ray is here too. Okay, well, let's continue then. Well, here it was a question. You have read it already. I don't think it's anything new. Look, it's change of color, and let's see. Look, what is important in a chemical reaction representation? Well, to the left are the reactants, and to the right are the products. Always, always, always. And this arrow means yield. Then the reaction between the reactants yield this product. Got it? That's the meaning of this arrow. Let's see somebody's. Okay, now Mireya is here. Okay, welcome, Mireya. Well, what is also important in a chemical reaction? Not only the reactants and the products. Also, it's important that matter cannot be created or destroyed. What does it mean? That the number of any of the reactants, any of the atoms of the reactants must be the same number of atoms of the same kind in the products. All right. For example, let me go back here. Look, one atom of carbon, one atom of carbon. 4 hydrogen. Oh, here I have 2. Then what am I supposed to do in this case? I'm supposed to put a 2 in front of here in order that I have 4 hydrogen. Now, 4 hydrogen, 4 hydrogen, 1 carbon, 1 carbon. Let's see. Here I have here also 2 oxygen. Then we have all 4 oxygen in the products. To do in order to get also 4 oxygen? Well, I put a 2 in front oxygen, 4 oxygen, 1 carbon, 1 carbon, and 4 hydrogen. Remember, you cannot only can change the coefficients. The coefficients represent the number of moles, and these subscripts indicate the number of atoms. Got it? Then you cannot change in water this subscript because water is made of 2 atoms of hydrogen and only 1 of oxygen. This number cannot be changed, but this coefficient, yes. And here is where we work on in order to balance the chemical equation. The balance in the chemical equation is based on the law of conservation of mass. Mass cannot be created or destroyed, only can be transformed. And of course, here you have methane and oxygen. And because of this reaction, at the end you have carbon dioxide and water. Got it? Any question here? No questions?
No, no questions.
Okay, let's go here. For example, well, here is what I was talking about, but not so represented this way. But I prefer, let me add here, let me add here a slide, and let me show you something else. Okay, I'm going to use the, okay, look at this. If you have, for example, calcium carbonate, calcium, because of this reaction, you have calcium oxide, carbon dioxide. Say, here, and here I have 1 carbon, and here I have 3 oxygen. I'm talking about atoms, okay? And here you have 1 here and 2 here, and the number question is the same. You say that the question is, and this is another example where we have, for example, carbonate plus, and the products are sodium sulfate and sodium sulfate and water, carbon dioxide. Okay, so 2, here is it. How many atoms of sodium? 2 atoms of sodium. How many have here? How many atoms of carbon? 1 carbon. Well, when I is, well, carbon, 2 hydrogen, 3 here, and 4 here is 7 oxygen. Got it? And 2 hydrogen here. Well, in this thing, I have 1. Oh, I forgot about sulfur. 1 sulfur. Then I have here 2 hydrogen. 4 space also, the question is balanced. But this is the way I have to follow in order to see if my equation is balanced. Line in here.
I see.
And then you divide, you say number of atoms of sodium, this I have in the products. And then one by one. If there is a difference, then you begin changing the coefficient. Let me put a more difficult one. For example, I have here sodium hydroxide, iron. So hey, then you make a line here. One oxygen here is affecting the oxygen and the hydrogen. Then you have to say that you have 3 and only 1 hydrogen. Well, as you wrote 2 times the oxygen, what you can do, have 3, say, have 3 oxygen, do that, all of the equation of the substance, the number 3, then you have, so, and the hydrogen is also affected by the 3 hydrogen, 1 iron, 1 iron. Oh, but here by putting 3, you react, and now the equation is balanced. Got it?
Yes.
Now you know
Makes
how
it
to
so-
balance equations. This
on the
procedure
PowerPoint.
is the
Why don't
Sorry?
you put that on the PowerPoint?
well, I am going to send you the video. I will send you the video, and in order to get some practice, okay?
You're setting
I
us
will
up.
I don't listen to you very
Sorry.
well. Anna.
Maybe can you hear me better? I'm gonna put my AirPods on.
It's some noise around you.
Yeah, I'm at work.
Okay. Anna, I am telling you that I'm going to publish. I'm going to send you the video, okay? Then you
Okay,
can
sounds good.
you can see it at any time. Okay, I am recording this explanation. Okay, I think that somebody is typing in the chat. Let's see. It was Mireya. Mireya. Okay, good. Okay, let's continue then. What is also important in a chemical reaction? We need to write the state. They can be solid, liquid, gas, or if the substance is in aqueous. What is the other thing? Look at this. Here we have potassium in the solid state in front of water that is liquid. The reaction between this metal and water is very, very strong. It produces hydrogen and potassium hydroxide. Well, it's important to say that the potassium is solid, that hydrogen is a gas, so it goes to the environment, yeah? And by the way, it combines with the environment and vapor and the flame and a lot of energy is released. This is a very, very dangerous reaction. And then produces potassium hydroxide that is soluble. So as the substance is soluble, we put AQ. It's in water, dissolved in water. Got it? Then here I am talking only about the states. It is very important to type the states of every substance. Any question about this? No?
No.
Okay, let's go. Okay, here we have a question. When blue light shines on a mixture of hydrogen gas and chlorine gas, the elements react explosively to form gaseous hydrochloric acid. What is the imbalance? Okay. What is important here? Well, you say, here I have 2 hydrogen, and here I have only 1. Oh, it is not balanced. It is not balanced at all, because here I have 6 hydrogen, and here only 1. Only. Well, but this equation is not okay, because here I have carbon and here I have chlorine, but it is completely wrong. Got it? Carbon cannot produce chlorine. It's a mistake. Here I have chlorine, chlorine. Here is also a mistake, because hydrogen, chlorine, hydrogen, chlorine, iodine, all the group, the 7 in the periodic table, iodine, bromine, all them are diatomic. They are always diatomic. Is diatomic. Then this is a mistake. Then this reaction is not okay. Let's go here. Then let's go here. Hydrogen, look, you begin reading. A mixture of hydrogen gas. This is hydrogen gas. That's, oh, this is chlorine gas. Then I have a mixture of hydrogen gas and chlorine gas. And to form, okay, here it is. Gaseous hydrogen chloride. That's good. Well, this equation is unbalanced because I need to put a 2 in front of 2 chlorine, 2 chlorine. Now it's balanced. Okay? But the question was, what is the unbalanced equation? And by the way, it's unbalanced. Got it?
Got it.
Questions? No questions?
No.
No.
We are going in one. Writing balanced equation for a chemical reaction. Well, as I told you, atoms are neither created nor destroyed. Then you have the same number of atoms in the reactants than in the products. Let's continue. Here is the same thing that I already explained. Yeah, it was the explode. And here Is what I told you. You make a line here. You say, you don't have to do this. You can say, I have 2 hydrogen, and here I have reactants, and I have only 1 oxygen in the reactant. So the question is not balanced. How can I have 2 oxygen here? All molecule. But now I have 4 hydrogen. 2 and 2 is 4. Oh, I put a 2 in front of here, and then I will have 2 more hydrogen. Then I will have 3 and 4 hydrogen, 2 oxygen, 2 oxygen. Now the question is balanced. Got it? Do you want me to repeat this example? Or does
Yeah, it's good.
yeah, do you understand?
Yeah.
Yep.
Yes.
Anna?
Yes, I understand.
Oh,
I'm trying to figure out how can y'all hear me?
Yes.
Yes.
I can hear you
Okay.
now.
Okay.
Okay, when you don't understand something, just tell me that. Okay, I read now to remove or remove time limit. Oh, we have time already. Okay. This was what I was explaining you. All right. Here we have another equation. This is the equation they are talking about. They want you to tell what is the correct balance equation. Well, what I'm going to do is to do the process. I'm going to do the process, add a new slide. Calcium oxide that produces or yield carbon. Let me see. Carbide. Calcium carbide. Calcium carbide. Carbon dioxide. Okay, let's see. Oxygen, oxygen, carbon. How many calcium? 1. And here, only 1. How many oxygen? 2. Here is only 1. Here I have how many? 2. Here is a difference. So let's begin by here. But it is also affecting calcium. Now I have 2 calciums, 2 oxygen. No problem with oxygen, but I need 2 calcium this side. Then here I put a 2 in front of here. Now I have 2 calcium, but also I have 4 carbon is 4 carbon. Oh, and 1 here and 1 here is 5. It's 5 carbon. And here I have only 1. Then what I have to do, I multiply by 5 here. And now it's balanced because I have 5 carbon, 2 oxygen, 2 oxygen. And then I have 2 calcium, 2 calcium. Balanced. Got it?
Yes.
Where did you get the +1 again?
What?
The +1, like on the left, the right side, 2 Ca, C2, then you put +1 on the top. Is that the charge?
No. Look at this. Here you multiply this 2 by this 2. And here you will have 4 carbon, yeah?
Okay.
This is a plus sign in between because here you have also. Got it? You understand why we have
Yes.
4? Somebody told me, I don't know who was. I thought that only in math we have a question. I told him, no, we have also in chemistry because math is like the basement of all the sciences. We use math in our language to explain the chemical reactions. Okay, no question about this?
No.
Let's go. Well, balancing chemical equations. The number of atoms each side of each type of elements must be the same in both sides. Remember, why? Because matter is not created or destroyed, only transformed. Subscripts must not be changed. The ratio of the number of molecules, okay? And the coefficients can be fractions. What does it mean? For example, carbon, let me see, produces a carbon dioxide. Sometimes I have 1 carbon, 4 hydrogen, 4 hydrogen, but now I have 2. And so I put in a 2, it's okay. But sometimes we can put, for example, 5 seconds. For example, you have dioxygen, then you cancel this with this, and you have 5 oxygen. Then you can use fractions to a specific case. You can multiply everything by 2, and then the equation will have no fractions. It's a specific example. Okay, that's all for here. Let me go now to the following lecture.
Yeah,
Let me-
chapter 7 is the one I was really confused about.
Same.
I know that this is the most difficult for you,
Both of them.
but you will see that is pretty much easy. Well, in order to begin explaining this, I want you, okay, to follow. I want you to follow the solubility rules. This is, you can print it. You can print it for the for the second exam, okay? Because if not, you're not going to be able to memorize everything, all right?
Okay.
For example, most nitrates are soluble. Then every time you see an NO3, you say soluble. And remember that when you say soluble, you put, for example, NaNO3. This is a nitrate, sodium nitrate, and then you put water. All right? And every time they are soluble in water, it means that you have then in the ionic form, nitrate. And then you're supposed to put the sodium positive. Got it? Well, every time you see they are soluble, and you put them in ionic form, you have to divide into ions. Got it? Every time you